Okay, a quick final video tutorial to finish off our worked examples for the holiday homework. We've got examples 10 and 11 and a little bit of a summary of the final three graphs on the board here. Question 10 is a really good one in terms of asking a little bit more of your understanding of this particular part of the course. You're going to see a lot of exam questions of this nature as well, so it's important that you get familiar with these. And when you see these types of questions in the textbook, when you're working through exercises, you really make a conscious effort to understand, and if you don't, you seek help and you do something about it. Here we're faced with a quadratic equation with a parameter, some other variable involved as well. So we've seen on one of the previous linear equations, we can have a parameter, in that case it was a, where we changed a, we changed to gradient. Now in this particular example we've got k occurring twice in our quadratic equation, and we've got this set equal to 0. Now we're not interested in what the solutions are, we're only interested in how many solutions there could possibly be. So the work that you're looking at here for quadratic equations is through the quadratic formula. In particular, we don't want to know what the solution is, we want to know how many solutions. So anytime you want to know how many solutions to a quadratic, you're interested in the discriminant and the values of the discriminant. So you first met this back in year 10, where the discriminant is known as b squared minus 4ac. It's the part under the square root sign in the quadratic equation, quadratic formula. So here's our a value, here's our b value, and here's our c value. At this stage here we're just going to plug these in, a, b and c, into the discriminant, and we'll come up with this particular value, evaluate these particular parts, and you'll get a secondary level quadratic equation here. So our discriminant is 4k squared plus 4k plus 4. Now tempting as it is to do some cancelling, cancel out those 4's, we're not solving that, we're not actually dividing both sides by 4, so that is the discriminant, just leave that as the discriminant. Now what we're really asked in the question is, for what values of k would we get at least one solution? So to get at least one solution, we don't want a negative value for the discriminant. A negative value for the discriminant means we have no solutions, or no intercepts if we graph it. So we want at least 1, so we want at least 0 for the value of the discriminant. A number of different ways to answer this is to show that question. I think probably the best way to illustrate this particular point is to actually look at what values the discriminant could take depending on what k is. Okay, so if we were able to graph this separately, so this is a separate function to the original function, this is a graph of the discriminant on the y-axis against k values on the x-axis. So as you change your k values, you will change the discriminant. And what we notice here when we plot this particular graph is the range of this graph is 3 to infinity. So I'm not interested in the fact that it's 3 to infinity, I'm interested in the fact that the range is always positive. There's no k value that I can put into this value here, which gives me a negative discriminant. So if that's the case there, I've successfully shown that the discriminant is always greater than 0 because the range of that graph is always greater than 0. Now probably a final statement actually making that conclusion would be necessary, but I've run out of board space in that particular example. But you can see there graphically how that illustrates and how that answers that particular part of the show, that question. Moving on to question 11. Question 11 is a reasonably straightforward question with a parabola. You've been asked to find the domain and the range. Well, unless there's restrictions, the domain of a parabola is all real numbers. You can either write that as r or round brackets minus infinity to infinity. And our range comes from the minimum turning point, which has a y coordinate of -4. No restrictions on the upper limit, so we go all the way to infinity with a round bracket. Questions 12 to 14 I won't do on the board, I'll put them separately up from the CAS calculator screenshots. They all set up the same way. You're interested in x-intercepts, and all of those graphs are given to you in intercept form. So null factor law will find you your x-intercepts. You don't need to do a full expansion to find the y-intercept, you just need to expand the constants at the end, and you'll come up with the y-intercept. And after you've got that, you're really connecting information together, understanding whether it's a positive or negative shape. So a positive shape goes up to the right, a negative shape would go down to the right. Connect it all up, and you'll have those variety of graphs. Anything from a parabola, I think there's one through to a polynomial of degree 5. But that's what's covered in the last couple of questions, and as I said, I'll put solutions up there with the CAS screenshots. Okay, that's all. Make sure you get those holiday homework examples finished, and when we get back, we will be looking at more work on linear equations. Okay, thank you.